All right, we're on day 3 of limits, and we're still working on some methods to identify the limit of a function. So let's set up a pen first before we begin. Today is specifically 2 very important trig limits that we need to look at first, and when we're finished with this lesson, I will just want you to put these to memory and not have to think about them again. So the first one we're going to look at is the limit as x approaches 0 of sine of x over x. Again, the reason we are learning these couple of trig limits today is because you can use them to be able to evaluate other versions that include those in it. So the way we're going to look at it today is I'm going to look at a graphical version of it and maybe a little bit of the numerical, the table, so that we can see if we can figure out what that limit is. So I decided to set my table up. So if you push second window, you can get this table setup menu where you will have a table start, a delta table, and an independent and dependent variable. Table start would be where you want your table to begin its x values. The delta table is how much you want them to change by. And the independent variable is on automatic, so that it just automatically builds this table for us, and you always want the dependent on auto so that it will calculate the y values for you. All right, here we go. So then you go to your table, which is second graph, and it forms this table which starts with the value we asked it to find or to start with, and it changed by 0.01. And hopefully as we start to look at this, it seems to me that each of these values progressively, as we come closer and closer to 0, as we come closer and closer to 0, seem to be getting closer and closer to 1 to me. So I'm even going to get as close as I can. Well, as close as I can with this table. At 0, you'll notice here, it gives us an error because of that indeterminate form. Remember, we talked about if you evaluate sine of 0, you think about the unit circle, and you think about the angle 0 radians, and sine of that is going to be the y value. And if you evaluate the denominator at 0, you're going to also get 0 over 0 in that case, and that indeterminate form happens. And this is often what it shows up as in the table, not always, but often. And as we look on either side, how we have looked at graphical things before, when we looked on either side, it certainly appears to be getting closer and closer to 1 on either side. So we would then conclude, and this is again the thing I want you to commit to memory, that the limit as x approaches 0 of sine of x over x is 1. And just as a side note, a couple of side notes, you can only, lost my cursor, you can only use this when x is approaching 0, and if it's the other way, like x divided by sine of x, you can use it as well. All right, let's move on. Okay, so another important trig limit will be the limit as x approaches 0 of 1 minus cosine of x over x. And we're going to also look at a table. And I started it very, very close to 0 this time at negative 0.01, and I'm changing it by 1/1000th of the changing there. So as you look here, as we approach 0, again, notice that that error has happened at 0, not shocking, indeterminate form again. But we have these kind of strange numbers here on either side. In fact, we'll go one more out and we'll talk about each of those. So I'm going to pull out, I have this negative 1, e negative 3. I have this negative 5, e to the negative 4. I have the 5, e to the negative 4, and the 1, e to the negative 3. Let's talk about what those mean. On our calculator, when it pops out this e, it's a scientific notation though. So what really it is saying to us is -1 times 10 to the -3rd power, and -5 times 10 to the -4th power, and 5 times 10 to the -4th power, and 1 times 10 to the -3rd. Well, let's equate what's happening with that. This is the same thing if I write it out of scientific notation as -0.001. Remember that we put the decimal place 3 places back or to the left from where it was. This one is -0.0005 and so on, 0.0005 and 0.001. So if we notice, as we're coming in here from this side, we're getting close to 0, and as we're coming in this side, we're getting close to 0. One of them from below with negative values, one of them from above. So we then would conclude with this special trig limit that the limit as x approaches 0 of 1 minus cosine of x over x is 0. So those two limits are really, really important to know how to recognize them. And again, we could have, how I mentioned before, we could have the reciprocal of these two items, but we must be approaching 0 in order for this to work. Alrighty. So let's look at something that doesn't really look exactly like what we had and think about how we could use a couple of or one of the trig limits. So first off, I kind of need to remember that we can rewrite tangent of x as sine of x over cosine of x from your trig. And if we realize that, it's kind of hidden in my rewriting here, that there's my tangent of x, and over x still there. The reason I did that is so that we notice that this piece right here, with the limit attached to it, is one of the ones we memorized. So if we then evaluate cosine at 0, remember from our unit circle discussion a little bit ago, if we're at 0, the coordinate pair is 1, 0, and cosine is the x value, so we get 1 times 1 over 1, which gets me 1. So we use that special trig limit to help us. All right, so let's look at a different one. I want you to note that this one does not approach 0. So this one is a little different. We're not going to use one of our special limits that we just learned. We are going to try to plug in and see what happens. So let's do that. We have 1 minus tangent of pi over 4. Notice I dropped the limit because I am evaluating at pi over 4. So I then really need some knowledge of the unit circle here to help me out. So pi force is the same as 45 degrees. And we have root 2 over 2. Root 2 over 2 is the ordered pair that belongs there. So if we realize what tangent is, tangent of the angle there, tangent of 45 degrees, or pi over 4, is the y value over the x value. The y value over the x value. So that nicely comes out to be 1 when we have that ratio. So I have 1 subtract 1 on top. This is great news. Well, kind of. We know that we have 0 on top, but I can't assume it's 0 for an answer until I know that it's not indeterminate, meaning 0 on the bottom. So let's check this. So sine, oh no, is pi force. Sine of pi force is root 2 over 2, the y value there, minus root 2 over 2 x value there. So that is indeterminate. All right. Indeterminate form means we must do something else. All right, so back to the drawing board. Let's see. All right, so we're back to kind of the drawing board, and we're going to need to rewrite this. And so my first instinct is to rewrite the tangent as a ratio of sine of x over cosine of x. So that's what I'm going to do first. And still all over sine of x minus cosine of x. And then I'm going to get a common denominator in the top portion, which would be cosine of x. So I'm here with my limit notation still on there. And that's going to lead me to a cosine of x minus sine of x all over cosine of x, still all over the sine of x minus cosine of x. Now I can rewrite this a little differently, remembering some algebraic rules. If I have division here, I can multiply by a reciprocal. So I have a limit as x approaches pi fourths of cosine of x minus sine of x over cosine of x multiplied by the reciprocal of that denominator. And then I'm noticing that these two pieces, this numerator, this denominator, are almost the same. They're a difference of multiplying one of them by -1. So I could factor out a -1 out of the top. So I'm going to get a negative, and then I have a minus a cosine of x plus a sine of x on top over cosine of x times 1 over sine of x minus cosine of x. And I want you to notice that this is sine of x, this is sine of x, minus cosine of x. This is sine of x minus cosine of x. They're just in a different order. So we can go ahead and cancel now, leaving that -1 in the numerator. Let's clean it up a little bit. Limit as x approaches pi fourths of -1 over cosine of x. So let's try to evaluate and get -1 over cosine of pi fourths. Let's remember back to our ordered pair that was at pi fourths. And we need, I'm going to go this direction, we need to put -1 over the x value. So I've got √2 over 2. That's fine with me for an answer, but I think you might have to go a little further if it were a multiple choice type of question. So let's go a little bit further. This would be -1 times the reciprocal. And coming around this direction, that would be -2 over √2, which in algebra we must get rid of the radical in the denominator, which leads me to -√2 over 2, -2 times √2 over 2, cancel, and leaves me with -2, √2. Well, that one took a bit more effort, and we actually didn't use any of the two that I'm asking you to memorize, but we did use a little bit of the common denominator from our previous method. All right, if you need to preview any of the homework, it might be a good idea. We're going to work on that next class period, this section that deals specifically with our trig limits. All right, we will see you soon.